Hello and welcome back to Maths with Mitch. Today's video is on trigonometry and the unit circle. So in the last video we did an introduction to trigonometry and looked at the basic ratios and applied them to the internal angles in a right angled triangle. Now one of the things we talked about in that video was how we're going to use trig in future and particularly applying it to vectors. Now a vector has a direction, so it might not be an acute angle as in the right angle triangles we looked at. It might be acting in a different direction, and we need something else that's going to help us use that and determine the directionality of that vector. One thing we can do is use the unit circle, and we'll look at how we can visualize the ratios in the unit circle, what it's showing, and how we can determine direction in the unit circle. So here we have the unit circle. So the unit circle describes a circle where the radius is 1. So we can use that to plot some points. So if we were to look at this first point at the top of the graph, we can say that that is at 0 in the x direction and 1 in the y direction. So we can say those are the coordinates of that point. And likewise down here, we can say 1 in the x direction and 0 in the y direction. Okay, so we're going to leave it there for the moment, but we're going to talk about why that's important and plot a few more points and then talk about how this works with trigonometry. So the first thing for the unit circle is to think that the radius is 1 at every point. Now if we were to draw a line out to the radius, we can make a right angled triangle like so. And now we can think in terms of our trigonometric ratios, what some of these things represent. So the first thing to note for the unit circle is we can measure the angle of the internal angle of the triangle, and that's always measured from the x-axis and is positive in that direction. So we can say angle phi, and it's acting in this direction. This line at the top, it's the longest side of our right angle triangle, it's the hypotenuse. And because it's a unit circle, we can say that the length of the hypotenuse is 1. So remembering our ratios, and we can write down SOHCAHTOA in case we forget, let's look at one of the lines to start with. So let's look at this acting on the bottom here. So that is using the adjacent, so we're going to be using cos. So we can say cos of the angle is adjacent over hypotenuse, but we've just said that the hypotenuse is 1. So we know for this triangle, hypotenuse is 1. So we can now just say cos theta is the length adjacent for this unit circle. So what we're now saying is that this length here in the x direction is given by cos theta. So if we were to now plot the coordinates for this point at the top, we can say in the x direction it is cos theta. So what about the y direction? Well, we can use trig again. So this time we're going to be looking at the vertical side here, the length there. Now that's the opposite, so we're going to use sine. So we can say sine theta is opposite over hypotenuse. But again, if we say the hypotenuse is 1, which we've already defined, we can say sine of theta is the length of the opposite side. So now we can say the coordinate of the point in the y direction is given by sine theta. So now that opens up a whole host of possibilities because we can now define the coordinate point as we rotate around the circle using cos theta and sine theta. We've now said that cos theta represents the horizontal distance, sine theta represents the vertical distance. So what does tan mean? So tan actually, as the name suggests, tan stands for tangent, and that represents the tangent of the line shown here, the tangent being a line which touches the edge of the circle once, and that point is perpendicular to the hypotenuse of this triangle. So there would be, it's 90 degrees here to the radius, and the length of the line tan is to where it crosses the x-axis. Now that we've defined that the point at the edge of the circle can be defined by cos theta, sine theta as a coordinate system, we can look at a few of the special cases that we mentioned previously and define some of the coordinates. So the first is to look at this line, which is at 45 degrees as measured here. So when we talk about the angle, we're always talking about measuring anti-clockwise from the x direction, so from the x-axis, so don't forget that. And we can define this point. So we said previously cos 45 was root 2 over 2. And in the y direction, it was also root 2 over 2. So we can define the coordinate system, the coordinates. The other one we looked at was 30 degrees, and we looked at 60 degrees. So we can write those in as well. Remembering we're looking at this angle here, so this is 30 degrees. We said cos 30 was root 3 over 2, and sine 30 was half, and it was the opposite way around for 60 degrees. Okay, so there's some special triangles that you can remember for the unit circle, and you may use them to do some trigonometry without a calculator, for example, if you were given some specific triangles. One way to remember it, if you were ever asked it for an exam or have to draw it out, is to think the left-hand side, the numbers are ascending, 1, 2, 3, and on the right-hand side, they're descending, so 3, 2, 1. Next, I want to consider the coordinate system that we're working in here. So as with any graph, when you're to the right-hand side and to the above the origin, so above the 0 point, we are in the plus domain in this quadrant. So here we have cos theta and sine theta are both in the positive direction. So what about if I'm over in this quadrant? We're still above the x-axis, so we are positive in terms of sine theta, but we are to the left of the y-axis, so we're now negative in terms of cos theta. So we can do a very similar exercise, and we can draw those lines on and consider similar lines in terms of where they are in the quadrant, but we now need to consider that we are still measuring from the x direction, from the x-axis here in terms of the angle. So we're now looking at 90 plus 30. So this first one would be 120 degrees. The second, 90 plus 45, so we're talking about 135 degrees. And the final one is 90 plus 60, so 150 degrees. But we know the coordinates because they're based on the same triangles. So here we can say horizontally it is negative a half, but in the vertical direction it's still positive, so it's still root 3 over 2. Here we're negative in the horizontal direction, so negative root 2 over 2 and positive root 2 over 2. And here we are negative root 3 over 2 and positive a half. So therefore for this quadrant we can say we are negative in terms of cos theta and positive in terms of sine theta. And we can repeat that exercise again looking at the other two quadrants. So once we've done that for the other two quadrants, it should look like this. And the thing to think about here is, where are we in terms of positive and negative? So in this bottom left, where we've drawn in green, we are below the x-axis, so vertically we are negative, and we are to the left of the y-axis, so we're also negative in terms of the horizontal. So that means we have a negative in terms of cos theta and a negative in terms of sine theta. And that leaves us with purple, where we are positive for cos theta and negative for sine theta. So the final thing we can think about is the tan function. So tan, is that going to be positive or negative in each quadrant? So let's remind ourselves, tan is opposite over adjacent. But instead of opposite over adjacent this time, where we said this was opposite, this was adjacent, we can define it in terms of cos and sine, because we're now saying this is cos theta and this is sine theta. So we can now say sine theta is tan theta, is sine theta over cos theta. And we can use that to then think about whether tan is going to be positive or negative in each quadrant. So remembering our positives and negatives and how they work in division, we can say a positive over a positive, so we know tan is going to be positive. We have a positive for sine divided by a negative, so that's going to give a negative tan. We have a negative and a negative, so they will make a positive, and a positive and a negative here, so we'll end up with a negative tan. So that's the unit circle. You've been able to visualize what cos theta and sine theta are in terms of the unit circle, and also what tan is. And from that you can use it to understand with some of the special triangles some coordinate points and determine whether cos, sine or tan are going to be positive or negative depending on which area, which quadrant of the unit circle you're operating in.